Hi everyone, we welcome you all to this week Tech Tuesday webinar on IICS Log Aggregation. Today's speaker is Matthew Bodman, who's a Principal Consultant from Informatica Professional Services. Before we start the session, let's go through some of the housekeeping tips. The webinar is for 1 hour that includes 15 minutes Q&A. You can post your queries in Q&A box which will be answered at the end of the presentation. All participants will be muted during the presentation. The session will be recorded and it will be available on our InfoSupport YouTube channel and Success Portal, where you'll be able to download the slide deck. Please feel free to submit your suggestion or feedback for this session in the post-webinar survey. The Success Portal is a micro-learning platform that offers free, unlimited learning to all registered users. This feature-rich platform helps you learn and adopt to Informatica products better. The following are few important links that you can go over later. This will help you in your product adoption journey with Informatica. Over to you, Matthew. Thank you.
Hi, thank you for the introduction. Welcome everyone. This is Matt Boardman with IPS. Thanks for joining. This webinar is to talk about enterprise log aggregation. In this session, we'll talk about what we mean by log aggregation at an enterprise level, some of the use cases for DevOps teams, and how it can add value for an organization. We'll take a look at the Operational Insights service in the Informatica Cloud and describe some of the available features for monitoring your Informatica infrastructure. We'll also show an example of a solution architecture that can help provide the same information to your enterprise log aggregation system. We'll take a look at the Informatica ICDM platform API and how this can be used by tools such as the Informatica Cloud Data Integration, CDI, to pull logging information from the Informatica Cloud. We'll go through a demo of how to extract logs from the Informatica Cloud. We'll walk through an example dashboard that we created using Microsoft Power BI, just as an example, and show some of the insight that you can derive based on these enterprise logging tools. Then we'll show you how you can go about building your own logging solution using a document store database such as MongoDB with the canonical data model based on Log4j. My colleague Jim will walk us through a demo on this, extracting logs from the security agents and uploading them into MongoDB. So what do we mean when we say enterprise log aggregation? All these systems and applications we have across the organization interacting with each other, the flow of information from one system to another. As these processes run, they all generate runtime logging information for later analysis or debugging. Usually those logs are ignored or simply archived for auditing purposes, but there's a lot of valuable insight to be gained from these log files. I would define enterprise log aggregation as a way of gaining insight into cross-application operational metrics at an enterprise level. So what we'd like to accomplish is tuning and optimization of those processes, orchestration, even predictive analytics. This can be useful for security, for real-time threat detection, or for auditing and regulatory compliance. There's many tools out there that can do this kind of thing. Splunk Enterprise is probably the biggest enterprise tool out there. There's also the ELK stack, which is Elasticsearch, Logstash, and Kibana. That's an open source stack that's available. And then the cloud providers have their own, such as Amazon CloudWatch, Azure Monitor, which was formerly Azure Log Analytics, and Google Cloud Logging. So some of the use cases here for operations, this provides a single at-a-glance dashboard. It's one place to check instead of having to scroll through multiple pages and multiple applications. This can reduce their time for resolving issues. We can talk about root cause analysis of intermittent failures, which is always difficult to debug. For example, when a process fails on one system, what else is happening on the network? Is an Oracle database doing a huge backup at that time, for example? Network failure prediction. So using predictive analytics to identify outages and disruptions before they happen. From a development point of view, we could think about long-running processes. Well, for example, Informatica doesn't know if an Oracle index gets dropped. All it knows is that suddenly its inserts are taking way longer than they normally do. Same with increasing runtimes that are slowly increasing over time. Informatica doesn't know about an Oracle table space that's maybe growing too large and it might require a DBA to either add partitioning or add some compression, free space reduction, increasing block sizes. So this provides This provides insight into something that's changing slowly over time before it becomes an issue. And as mentioned, also process orchestration, tuning and optimization across multiple applications. So within the Informatica Cloud, we provide a service called Operational Insights. This service provides Informatica dashboards for not only for the cloud, but also for monitoring your Power Center, IDQ, data engineering, all of that infrastructure. You can have insights into cloud data profiling, data integration, application integration, even mass ingestion. It also provides infrastructure email alerts, such as when an agent goes offline or when an agent is over thresholds that you can set based on its current CPU usage, memory usage, disk usage. So now let's take a look at an example of a solution architecture we could use to feed data to these enterprise logging solutions. First, when we look at an IICS secure agent, you can see that each service generates their own logs, as well as the agent itself generating several logs. All of these logs are useful, but they're in many different locations, depending on which services each secure agent is running. So for example, a typical secure agent, you might have the agent core log for startup and shutdown. You may have the Tomcat log to check connector status and so on. But you may also want to have a look at the data integration services and the session logs, task flow logs, bad files, anything that comes from that. In addition to the secure agents, there are also some logs that are only available from Informatica Cloud. For example, here we're looking at the administrator interface, security logs, and you can see that this is really a list of user logins and logouts. So because a user never logs into a secure agent directly, only through the cloud, these logs can only be downloaded from the administrator checklist within the IICS Cloud. So here we see an example of a potential solution architecture that takes care of both of those problems. First of all, for the logs on each secure agent, just like any other application, you can have here a agent of that aggregation technology. For example, you could have a Splunk agent, or Azure has their own agent. They can pull those log locations just from a list. And as those files become updated, or if they're available, as new ones are created, they get shipped off to Splunk Enterprise or Azure itself, depending on how you set it up, for analytics and insights that can be real time. For the cloud logs that are only available from the informaticacloud.com, we have to use the platform API. This can be done through a REST connector on the secure agent. So we can create, for example, a CDI process or a CAI process that interfaces with our platform API, pulls down the log information, and writes it somewhere. So maybe it's writing it to another file on the secure agent. In this case, it would have to be shared storage if there's more than one agent in the secure agent group that it's running on. since we can't control which agent within the group might be running at any given time. And then it would again be pulled from that log location using the agent and then sent off for analysis. So we've seen this kind of architecture work well for a couple of our customers in the past. I've had a cloud architect come to me and say, I'm only interested in login information. That's what I need. So then this top path going through the REST connector and the platform API and then through this secured storage at the bottom is all that they really need. In other cases, you may want to have debugging information, you may want to have auditing information, you may want to bring over the session logs for each of the workflows, task flows that are running. You can bring in logs from other Informatica products such as PowerCenter, IDQ, data engineering. Even the MDM has many different logs depending on whether you're using JBoss or WebSphere or WebLogic application servers. Most of our Informatica logs follow the same log4j format. So we'll see an example of that later on in the demo as how we can use Perl scripts to simply bring in those log4j files and upload them. So now let's take a closer look at the Informatica Cloud Platform API. Here I have Postman running, and I'm looking at the login API. So this goes to our URL on the cloud, regardless of the org that you have. It's the same URL for everybody. It goes to SaaS Public Core v3 login. You specify a username and password, and it gives you back a session token. You can paste this session token here into our header value, info session ID, that will then be used to load the assets and security logs. This URL, you'll notice, is slightly different. Now we are having to specify that we're on the NA1 pod. And for example, the security log, you can specify that you want the entry time between two values, two timestamps. So I'm giving it between this timestamp and this timestamp. And here what comes back is a list of authentications and logins, logouts. You can see here we have a password reset event. It's a long list of activities that have happened between those two timestamps. I believe there is a maximum on here of 2 weeks, 14 days. So long as you run this process once every 2 weeks, then you'll get all of the login information. Although more likely, you'd probably want to run this process at least once a day to be safe. You can see that a number of our other APIs work the same way. Give it a session ID, send off the request, and you get a JSON back. In this case, it's the asset logs, also called the audit logs. So these are, for example, migrations that have happened on this org, or even a developer updating a mapping. Those events all get captured as well. You can also capture CDI activity from the same API. It's a different operation. In this case, we can see there's a number of jobs that have been run. Here's me running a REST connector, REST API v2. So let's now take a look at how we might extract logs from the Informatica Cloud using data integration. The steps we want to follow are to create Swagger files. Swagger files are used to describe the REST API. Then based on those Swagger files, we can create a series of REST connectors. For our Swagger files that are generated from our administration checklist, the best idea is just to keep it to one operation at a time. So that means that each REST connector would be defined with a single operation as well. For example, you might define one with a login operation. Here we're going to build 4 of them. We're going to build mappings and mapping tasks to log in, get the session token, just as we did with Postman, to extract the security log, the asset log, and the CDI job log, and then we'll build a task flow that brings that all together. You can, of course, do much more than that. That's just what we're doing in the demo today. So for the Swagger files, these are all done through the administrator checklist. Right at the bottom, you'll see an option, Swagger files. We can create a new one here. And I'll just give it a name. So the runtime environment, I'm going to use my SAGMAT-P. The URL, we can take this directly from Postman. So this was our login. We can use this. Now, we're actually only interested in this part of the URL right now. We'll type in that with no extension. We're going to use no authentication because we're going to put that instead as part of the payload for this operation. The API base path, we're just going to use SAS. And for the API path, there's a number of options. You can see we have a V1, V2, V3 option. But in this case, I'm going to use the same as what I had in the Postman, which is the V3. Username and password don't actually matter. It's just Chrome filling it in for me automatically, helpfully. And that's it. Next, we want to give it the headers that are going to be used. In this case, there are no headers because we're doing the login in order to find the header. So rather than a get operation, we want to do a post operation. The login, it's a post operation. And we can give it an operation ID. And then our raw body can just be, for example, the same as we have in the Postman version. You can just paste that in. It doesn't matter what the username and password are. These will be parameterized later. Then for the JSON response file, if you leave this off, it'll just execute the raw body. But in this case, we don't want to do that because I don't want to save my password in the Swagger file. So we'll take this response here. We can save this as a new file. I'll put this on my desktop. Now it doesn't need to execute this operation because it already has the response file it needs. And we hit save. And it's created the new Swagger file. So one important thing is that when it creates the Swagger file, this is only here for your benefit. It doesn't actually do anything with it. So the first thing you want to do is download the Swagger file and place it in a location where the secure agent can access it. In my case, I've put all of these on my temp drive, or C temp Swagger. Next, you'll want to create a connection that uses the Swagger file. In my case, I've defined this in advance. That's here. This connection is really simple. All it needs to do is you give it a name, you give it the secure agent that it's going to run on, and then authentication type. In this case, there isn't any, and the location of the JSON file. And that's all it needs. In some cases, you might also want to configure a proxy, or if you're using SSL, you may need to give it also a trust drawer file path and password in JKS format. So now that we've defined our Swagger files, we've uploaded those Swagger files to the secure agent, and we've defined connections that use each of those Swagger files. Let's create some mappings to take advantage of that. So here I'm going to show you some mappings that I've defined already. We can take a look at the login mapping. This mapping's fairly simple. We just have a source connector here that uses the REST connector. And it's using the login operation. That's all we need to define. The fields we get back is a session ID. We can see that in the field mapping here, it has quite a few available fields. What we're only interested in for now is the user info that's passed back on response 200. So we've mapped the session ID. That's what it's going to bring across. You see it here in the output fields. So we're going to create a session key expression here. And the reason for that is I want to define a parameter that's going to be used to push this session key out to the other mappings. That way we only need to log in once, and we can run the other three mappings to get the log for security, the log for audit assets, and the log for CDI jobs all at the same time without having to log in again. So the way we do that is through an expression transformation. We just set this in-out parameter, param session key that I have defined on, you can here see on the right. I'm just going to pass that in to whatever the value of session ID is. I'm also using a login parameter here, which by default has nothing in it for the user and password. You can see that we also have to wrap this in a body tag, but otherwise it's the same as what we put into the Swagger file. We'll define what the username and password actually are in a parameter. Then the result of this is just to pass it to a dummy file. Doesn't actually do anything. I just have this set to be a flat file on my server. That's it. Then we create a mapping task based on that same mapping. Here's the mapping task. Let's edit this so you can see what it contains. All I've done is given it a name and a folder and tell it what runtime environment I want to run. In this case, it's the secure agent group map B. This is the mapping I'm going to be using. Now we can define what the in-out parameters are. Just going to have this one. You can see it has the value of the last time it ran retained. Then in the last tab, we can define where we want it to get this parameter file from, which contains the actual login information. So for me, I want to create this on my local drive where it's accessible by the secure agent. So I've got this as ctemp, and this is mt login v3.param. I've just given it a file name. Now, what should this parameter file look like? We can download a template that shows us exactly what we want it to look like, what this file should look like. Put this on the desktop. We can open that. So in our case, when we open this template, you can see that by default, it only has the session key, the in-out parameter. So what we want to do is initialize this to a null. So that's fine. But we also want to add our login parameter. And the format we want to use is this exact same one that we used in the Swagger file. But in this case, you can see it's using this body wrapper, just as we saw in the parameter default. That's just so that the JSON knows what to do. So you take this part of it here is what we actually have in the Swagger file and in Postman, and then we're wrapping it in this body tag. That's all we have to do. Okay, so now that we have our parameter file defined, we can say finish. That's our mapping task. We could run this as is, but what I'd like to show you next is how we can use this in a task flow. Here we see the task flow. You can see that I have 4 mapping tasks here. First of all, we do the login operation. And then if that login is successful, then we execute these other 3 mappings, one to get the security log, one to get the audit asset log, and one to get the CDI job log. So in order to make this work, we need to pass variables from this login mapping to each of these 3 mappings here. So as we mentioned, that's the in-out parameter for the session token. In order to do that, initially we set this param session key to a value of null. So this is, you can see in the path here, we've got mapping task login v3, in-out parameter, parameter session key, and the value we're giving it is null. So we can define those same in-out parameters, the session key, in each of these mappings. Security log, audit log, job log. In the security log, it has the same session key. You can see this is the mapping task for the get security logs business service. In-out parameters, session key. But this time, we're going to initialize this to the session key that is coming from the login agent. So the login mapping task, its in-out parameter, param session key, is then used by each of these 3 sessions. So that way we only have to log in once, and all of these 3 mappings do the real work. The login successful criteria is just how many rows were passed. You remember that in that login, we gave it a dummy file. And if the number of rows returned in that dummy file is 1, then it's been successful. Otherwise, we've failed. and stop. And if that happens, you can add a notification task to tell the local administrator that something's gone wrong. But in this case, I'm not doing that yet. Then the next step is just to simply publish. As soon as you publish, it becomes accessible. And then we can run. If to check the current status, we look over at my job logs. You can see this has started to run. Let's take a look at the subtasks that it's running. We can see that 4 have been started. Now, on this secure agent, I've only allowed it to run 2 mapping tasks simultaneously. So the third one is just waiting. We can see the first one is past 1 successful row. That's the login operation. So now it's getting the audit logs and the security logs. Now it's finished those, and when we refresh, we see that it's finished all 3 of them. So all of these tasks were now processed. Now, in each of these cases here, these business service logs work slightly differently. I still give it an in-out parameter, so it's got the session key being passed. That's the same as we did with the login. It's just an in-out parameter. In this case, it's being used as an in. But if we take a look at the actual mapping here, we can see these 3 are not using the source as the REST connector, but instead we're using a web service. So this web service transformation, all you need to give it is the session key that you want to provide, and in this case, the queue or query that we're going to use, which is just built by this expression, just saying, here's the range of dates I want to use. In this case, for the expression, I have it set so that the query will be built based on the last time it ran. So it's taking this min from date, which is the last time it ran, or if it's null, then it's the current timestamp, converting that to a date, and then setting the time of that date to 0. And then we append to that the session start time, so the time that this particular mapping started, plus 1 day, and with, again, plus 1 day, but with the time set to 0 seconds. That way we're going at least from the last run date to current. In our web service, all we have to do is specify a business service. Those business services are built here. Here's the security business service. All you do here is specify what the connector is that you want to use. So in this case, I want to use the REST v2 connector that I created for the security log, which calls the security log Swagger file. You tell it which operation you want to run. You can configure it to have these particular input values. So we've got the session ID coming in as a header, and we've got the queue or query coming in as part of the URL. And it knows that the response coming back is a 200 when successful. It contains these events. That's what we want. All 3 of these work the same way, but in the activity log, it's a little bit more complex. Let's take a look at that. This is the job log. or CDI. You can again see again, it has the session ID. In this case, we don't need to give it a query parameter for dates. It just always gets the last 200 entries. But in the response we get here is a bit more complex. So first of all, it has many fields. Number of success rows, failed rows, context, type of operation, but also it has an array of entries. And these entries are also complex. This is an embedded object. Start time, end time of the mappings. Now, session variables, the transformation entries array is another third embedded type of object. In this case, I want to extract all of these because this last one here, transformation entries, contains the statistics for the sources and targets for each of these. So what is the target we're using? Well, in this case, I wanted to use SQL Server. So we don't have a connector that goes directly from, for example, from these mappings into, say, Splunk or Azure or the other cloud providers. Instead, what we can do is write this information out to a flat file where it'll get picked up by the agent, or we can use the, in this case, I'm just using SQL Server. We'll see in the next section how we can also use MongoDB, which is a document store database. The SQL Server is just fine for our purposes here today. Let's now take a look at how we can use this SQL Server information in a Microsoft Power BI dashboard. Of course, you can use any tool here. Tableau, MicroStrategy, Kibana, all kinds of reporting tools. But I'm just using Microsoft Power BI because I have it on my laptop. Let's take a look at this report. This is a live query to the SQL Server database, so it's always in real time. I want to stress that this was really easy to create. So just given the data model that comes directly out of the JSON, we're using pretty much the same thing here. It's the activity log entry, and the entry transforms, just as we saw. We've got the security log here and the audit log. So these tables are just directly what's out of the JSON. The only difference here is that I've added a little reference table to convert days 0, 1, 2 through 6 to a text mun, tu, wed, thur, fry, sat, sun. And then for our orgs, I've also created a little reference table that just says for this org ID, let's give it a name and a location so that in our actual dashboard, we can see, yeah, we're interested in IPS and A West, and that's in Oregon. And our other facilities here, we've got 2 other orgs that are in Virginia. But I don't have the information for those. But this is quite simple. We can see, well, this guy M. Boardman has been doing a bunch. Let's see what he's doing. And you can see that this particular user has been logging in, running some mappings. Well, this only tells you that he's logging in and logging out. It also gives you agent logins. So this red is the agent login, but it can't associate that to an individual user. We can see also Ruben. If I click on him, we can see that he was active a couple of weeks ago. Lots of login information. So this way we can try and find if there's any suspicious activity We also give the last few days of administrative activity. We can see Jim Johnston here has been creating a user. So this is all information that you might want to know. But how insightful is it? Well, this is just login information mostly for the purpose of auditing and tracking. But you can actually gain quite a bit of information here on what developers are really doing. So this is the activity log that comes from our assets and audits. As you can see, migration activity has been happening. There's been quite a lot in the last few days, a couple of weeks, more than normal, I would say. So a lot of these are, let's say, well, there's an awful lot of updates, but in reality, we know these updates are just from a mapping that's being developed. So this is actually development activity. In this case, it's me. You can see here. And it also shows other events that have happened, like export and import. There's been a move and a publish. Let's see, about a month ago, we had an import operation. Looks like that's Ruben again, importing some objects. So this way, you do have a level of understanding about what your developers, what your team leads are actually doing in each of these orgs. We can see here just a simple word cloud of the messages that are coming along as part of these job logs. We see successful is a common word, so that's a good thing. Swagger is probably me creating Swagger files. We can see a lot of updates and creates. A event is just a publish notification. Then on the right-hand side, this is just a simple visualization of who's doing what. So, for example, if I click on me, I'm orange for some reason, then I've got a mapping that I was working on yesterday, check time, and then this is the security logs, and it gives you a breakdown of what are the different activities that this shady character Matt has been doing. Let's try and see if he's doing anything suspicious. So this is really useful. Then in the CDI job logs, we can get some insight into what CDI is doing. So now I'm showing a little heat map of what processes have been running on this server by day. So we can see if we look at Mondays are usually busy on this server. Wednesdays are usually busy. This is over the past 90 days. And this is showing week month here. So over the past 90 days this way, we see the last 2 weeks in particular have been heavy on Monday and Wednesday. So this gives you an idea, especially if you have an elastic environment that you want to, for example, if you have end of the month or end of the quarter activity and you want to size up, this gives you good information about what kinds of processes are running during that time and how many you're running, how many rows. In this case, we've got 4 million rows going through over the period of the last 90 days. That can be pretty significant. And we can see on the far right, we can see what kind of errors people are getting. So there's a cluster error happening up. That's I think that's me. That's part of the activity I've been doing on the last couple of days. We can see mappings that have been running. You can break this down by failed rows, for example, or different process types. If I want to just see what happens on Monday, we can do that. So here's everything that's happening on a Monday. It's quite powerful. I want to stress that any technology can be used to create this. I just happen to have Power BI on my laptop, so that's what I used. Okay, so now we've seen the basic API calls, and to get the information from the Informatica cloud into a relational database that can now be queried with Power BI. But what do we do about all those other job logs? Well, one thing we can think about is using a document store database such as MongoDB rather than SQL Server. It's more suited to the task, and especially when you have a large number of files being ingested at an enterprise level. So we use MongoDB internally at Informatica. So for this project, we got access to start using the internal development MongoDB hosted, which is called Atlas. And I'm not trying to plug MongoDB in particular. It's just that this is what's available to me as a developer at the moment. We use this as an example. We do have a connector for MongoDB in Informatica, so Informatica can connect to this natively. You can see this is a connector that we used on the left. So a couple of things I learned about this connector is that it does require SSL mode. You can see that switched on here in this flag. We want to connect to the primary shard rather than the cluster of all three. So that's important to know. It needs to connect to a particular host. Usually this is the default port. That's what we're using here. I've created a user and password just for this project, and we gave it a database name. Everything else is pretty much automatic. We didn't need to define a schema in advance. We just tell MongoDB, here you go, here is a document in JSON format. Then once the data has now been uploaded into MongoDB, then you can use either MongoDB Compass, which is a GUI tool that MongoDB provides. That's what we see here on the right. This lets you look at each of the documents that are stored, or each of the logs that we've uploaded. Check that the formatting is correct. We can see that our canonical format has TSTZ, severity, class, and a message for each one. Or you can use the MongoDB BI connector, and that's how you would allow SQL to be run so that it can be used with tools such as Power BI and Tableau, MicroStrategy, SAP, kinds of BI tools. So let's now take a look at how we get the information into MongoDB.
Hi, this is Jim Johnstone. My part of this log aggregation hackathon was to parse some log files to get them ready for combining in Mongo. So I looked and found some likely looking log files on my hard drive generated by the secure agent, and did some analysis to find out what the different formats were. I found out they were all over the place. So I picked two as a proof of concept for this effort, wrote a Python script to read them and parse them to a canonical format, which I'll show you in a minute. The idea was to get them into some sort of a consistent format so they could be combined based on time in Mongo. So this is the Python script that does the work. The core of it's really here with the regex parsing. There's some file handling and there's some configuration here. So these are the two files that I did, where you can specify in JSON which files you want to process just to kind of factor out functionality and help it to be flexible for the future. Turned out this might have been overkill, but I only got as far as 2 log files before I ran out of time. So to run this, I can run it directly within this editor. I highly recommend, if you're dealing with Python, to use the Spider editor. This will run the file. Oops, I have to be in the Python. This will run the file, and you can see that it reads a particular couple files as specified in this JSON and outputs them to a directory over here. So these are the current files. I'll open the smaller one. It does take a little while to open in Notepad++. It's not too easy to read, but there's a handy plugin that you can use to make it more readable. This also checks the JSON format to make sure there's anything, not out of place. For instance, a missing comma there would break the JSON. So once I have that, I can post it to the Mongo database, which is here. So now you see we have 12 files, and I'm going to post this one. Get a handy key back from the code. This is the code that does the work. It's not integrated in Python yet. I did try with the request library, but hit a time box there. But basically, this is the key to update the JSON file to the Mongo database. So now if we refresh, we should have 13. So that shows that file made it to Mongo. And in a moment here, I will show you the canonical format. So it has some header data that will have to be expended over time if we're going to productionize this. And then each log row turns into a separate object within Mongo that looks like this. So each one has a timestamp, a time zone, severity, a class, and a message. In the case of a error stack, it would show just a timestamp in the error message, and then the timestamp would be correlated to the one before it. So that's pretty much it for my hands-on part of this hackathon. Again, it was a good learning experience. Learned a little bit about Mongo, more about Python, more about where the log files are for the agent, and how we can put them together.
Okay, perfect. Thank you, Jim. So we want to give thanks here to the Informatica Hackathon folks that were able to participate in and contribute to this work. Ben Lee, Jim Johnstone, Sri Lakshmi Subramaniam, and Emilio Masaki Nakashima. All of us were working as a team. This hackathon that we do annually provides cooperative learning environments. They're always lots of fun. We're solving new challenges that we haven't seen before. The idea is for our consultants to be able to learn, and also to work with our sales folks and product management teams and perhaps drive some new initiatives and new directions for our products. So thank you, everybody. I'll also include in the download section, there'll be a little link to the different API documentation that we have, as well as how to create the MongoDB connector. Thank you very much. It's been great to talk to you all this morning. Let's open up the floor to some questions. Hi, everybody. This is Matt. I hope you can hear me okay. We did have a couple of questions from participants, so I'll see if I can address some of those now. One was about the password being stored in plain text in a parameter file. And yes, that really is how it works. But what you can do is hide that parameter file either in, for example, cloud storage in S3, or an Azure blob, or even a shared folder that the secure agents have access to, but no one else does. So you can control that. It doesn't have to be in the same parameter file as all of your other mapping tasks. So that way, S3 and Azure Blob provide their own encryption. So it's protected in that sense. Hope that helps. There's also a question about CAI monitoring. I actually really wanted to get into that, and I had some other content, but I had to cut that for time, unfortunately. But yeah, do take a look at the Operational Insights applet on our cloud. There's also the CAI monitoring console, and they can give you some of that insight. Let's see what else. We've got a question about doing bulk loads of logs. Yeah, so that's a great question on the performance. That we did try a few other options. We tried, so first of all, if you're using Splunk or Elk or tools that are designed for this purpose, then it's not an issue. For us, we wanted to use MongoDB as an alternative to that. So first of all, we did use a CDI process that just read the logs using a file watcher, so that as a new session log comes in, it gets picked up by the file watcher and sent to a CDI task that sends it to MongoDB. And that worked just fine, but it's not really very performant, especially when you've got hundreds of processes being run across multiple secure agents. Then what we found was the best way to do it. You can see it right at the end of Jim's part of his demo just then. We used a curl command, and MongoDB, at least on the hosted platform, lets you use a curl to upload a document. So what Jim's process was doing was take a session log, transfer it from log4j format into JSON format so that it's canonical, matches everything else, and then use a curl to upload it in one step. And it worked great. It was just, it was really, really performant. You could also consider using mass ingestion. That would be another alternative. Mass ingestion for files is designed for the purpose of rapidly uploading lots and lots of files. So for example, if you wanted to do a mass ingestion process, say once a day, of all of the session logs of all agents, something like that would work really well too. That helps. I don't think one question. I don't think there's a Power BI connector for CDI, but what I was doing was I was using SQL Server as an in-between. So I was just writing out to SQL Server since I have it on my laptop, and then using Power BI's SQL Server connector. So that's just because that's what the tools that we had in front of us. A lot of the time for these hackathons, it's about learning the Informatica products, but it's also, learning to better use the tools that we have at hand. So I hope that helps. Is that all the questions? Oh, there was a question about how to get a recording. You will see the recording post afterwards. Anyone who's registered for the session will get an email momentarily telling you where you can download the recording. And if you take a look at the resource list on your screen, the slide deck should be available to download from there as well. Great, I hope I've answered everyone's questions. Please ping me if I haven't. Alrighty. Oh, sorry, did I see one more? Sorry, can you clarify the APIs? I'm sorry. Yes, so right at the end of the PDF of the slides, I had a link to all of the documentation that will, because there's a bunch of different APIs. There's the platform API, CAI API, CDI API, CMI, CIH, they all have their own API, and it does get confusing. So they're not all in one place. So that's why that last slide is important. It sends you to all of our documentation. They're all on docs.informatica.com, which doesn't require a login. MongoDB is, this connector information is there as well. I know I went over that pretty fast, so no worries. It's MongoDB is one of our built-in connectors for NoSQL. We have other NoSQL connectors as well, but MongoDB is one that's fairly well tested since we use it internally. That's how our MDM SaaS platform works as well. It also uses MongoDB in the backend. I hope I'm answering your question. Yeah, if you have Splunk at an enterprise level, that's probably where you want it to be in order to be consistent with your own company's policies. I'm just suggesting MongoDB in the case for maybe a customer that doesn't have Splunk, or if they're looking for a specific purpose, such as just wanting to archive the logs for security purposes and have them available for years and years and years, just sitting there just in case they're ever needed for any reason. Then MongoDB fills that purpose perfectly. But for analysis, yeah, I would use Splunk if you can, or this ELK stack, or the cloud providers built-in monitoring services. They're really good. And if you find that you need to aggregate that even further, like I've had a customer that has in a multi-cloud situation where they have Azure, they have AWS, and they also had their on-prem virtual machines as well, huge clouds. So for them, it makes sense to have something that's independent of the cloud provider. And so MongoDB might provide a good alternative for them as well. Oh, sorry, a couple more questions just popped into the chat. Certification, I don't think so, not on this one, but you can get certification for example, for CDI, for CAI. That's all through informaticauniversity.com. We might actually make this Tech Tuesdays part of the educational material, but usually we just make it available on our site for download and on YouTube as well through the support channel. Great, we're right at time. Thank you very much, everybody. Thank you for your time today. It's been great to talk with you all. Have a fantastic day.
Thank you, Matt. Thanks for your wonderful session. Brenda here. Just wanted to call out for all the webinar, Tech Tuesdays webinars, you can visit the Success portal where you'll be able to download the slide deck and view such sessions. Also, by tomorrow, the session will be uploaded to YouTube as well. Also, right after the session, we have a post-webinar survey. Please go through it and let us know your thoughts about this session. And if you have any future suggestions, please let us know through the survey. Thanks a lot. Once again, thanks a lot, Matt, for this wonderful session. See you on our next Tech Tuesdays. Bye.